Good afternoon. Good morning, students.
Morning, sir.
Good morning.
All right, happy to have you here. I revise some transformation today. Remember, we have some practice in class tomorrow and on Monday. All right. All right. So this is the May 2023 exam paper. Last exam that was set by CXC. And this is number 3C. You usually get a transformation question on number 3. And also sometimes you get one in number 10. So this is number 3. And we're looking at part C of the transformation question. And usually this transformation that comes in section 1 is usually one that you have to draw on a graph or read information from a graph, as you can see here. So it's a construction type of transformation. The one that you get in section 2 is usually the matrices type. We have to, do transformation, use the transformation matrices and carry out a calculation. All right, so let's look at this question. This question says the diagram below shows a trapezium A. Hold on a second. Guys. Sorry about this. Sammy. Yeah, Katie, I was saying, I sent you a WhatsApp. She said there's an order that she's supposed to get. And she needed it for today and tomorrow, or even today and tomorrow. I sent it to you in a WhatsApp. Okay? Oh, I don't know. Check it out and see if you can see what is happening with it coming up, please. Because some of them don't do. Yeah. Yeah, man, please. Yeah, thanks. All right, guys, sorry about that. Car came in at the wrong time. All right, I've been trying to get that person from morning, the person called me just as I start class. That's how it is. All right, so yeah, so they gave us this trapezium, it's trapezium A, and they show it on this square grid. This is a graph. All right, so naturally we're gonna have to answer some transformation questions related to this trapezium. So the first question, it says, on the diagram, we have to draw the image after it undergoes 1, a reflection in the line x equals -1. I have to label that one A prime. And then now we have to use the same quadrilateral or the same trapezium A and carry through a translation of vector 4, -7. I have to label that one A prime. All right, so the first one is a reflection in line x equals 1, x equals -1. So we have to draw that mirror line first on the graph, x equals -1. But x equals -1 is a vertical line passing through -1. So I'm going to draw the mirror line first. You want to see the line that you're reflecting over. So reflecting this now in the line x equals -1 is this line. We're reflecting in this line. This is our mirror line. I'm just going to draw it here and stop it right here. This is the x equal -1 line. And so we are doing a reflection of this. Now, when you're trying to do any transformation and you're trying to construct any transformation, a safe way to do it is to do it one point at a time. And I'm talking about the vertices on this object. So these are the vertices. I'm not going to name them, but those are the vertices. Usually give them letters like A, B, C, and D, but I'm not going to name them. All right? And let's say we are reflecting this one first. It is 2 units to the mirror line, and so it's going to go 2 units on the other side of the mirror line. So this point is coming right here when we reflect it. Image distance equals object distance. That's where that one will go. And then this point, that one is 1, 2, 3 units to the mirror line. So it's going to go 1, 2, 3 units on the other side to here. So that point is there. And this point is now 4 units. 1, 2, 3, 4 units of the mirror line is going to go 1, 2, 3, 4 units on the other side. It's coming straight across to here. So put down that point again. And you're at a stage now where you can literally draw it. But let's do this last point here. That one also is 4. 1, 2, 3, 4 to the mirror line. Gonna go 1, 2, 3, 4 on the other side. So it's coming right over to here. Right here. And now that you have your points in place, that is when you draw the shape. Oftentimes you try to draw the shape in one go and make a mistake. You don't want to make a mistake, and to reduce the mistake, you do it one point at a time. Remember, reflection is done by doing image distance equals object distance. We have to label this one A prime.
Brittany.
Mute your mic, please. Mute your mic. This one is A prime. All right. The next thing we have to do with this same that trapezium in part 2 is to do a translation 4, -7. What does 4, -7 mean? 4, -7, we're going to do the 4 first, which is a horizontal movement. It means 4 units to the right. We're going to move each point 4 units to the right. And this -7 is a vertical movement, but the negative means downwards. And so we're going to move it 7 units downwards. 7 units downwards. That's the -7 means 7 units downwards. So that's how this translation will work on each point. So a point here, we basically move to there by doing 4 to the right, 7 down. That's what this translation means. And so we're going to do that with each point. Move each point 4 to the right and 7 down. Now you can actually move 1 point, because what you know is that the shape will not change. So you can literally move 1 point and then draw the rest of the shape around that 1 point so that it stays the same shape. All right? So let's look at this. Let me do the movement in red or in purple. So let's say I'm going to use this point up here. I'm going to move that point 4 units to the right and 7 units down. So it's going to go 1, this point I'm moving. 1, 2, 3, 4. Takes me onto the y-axis. I'm going to move it 7 units down. 1, 2, 3, 4, 5, 6, 7. That point is coming to here. So since this point comes to there, I can basically draw the shape around that point. So we have this piece to the left from that point. So I can draw it. So I get this point first and draw this piece, which is this top piece. We have this 2 units down on this side, 2 units down. Then we have this 2 units across the base, 2 units across the base. And then we complete it with this diagonal piece or the slant piece. A diagonal slant piece. That's my shape. That is it. And I name this one A double prime. Now I could have also do it by calculation. Because let's say I take this same point, for example, which is -4, 4. That's what point is located. This point is -4, 4. And I want to see where it's going to go. So I have to do the translation on it. So it will be -4, 4, representing the coordinates of the point, plus a translation of 4, -7. And I add them, 4, -7. When I add the -4 and the 4, it tells me that that goes to 0 on the x-axis. 0 is the x coordinate of the point. And then 4 and -7 is -3. So it tells me that this point will move down to 0, -3. The point is, it means that -4, 4, which is this point, is moving to 0, -3 under the translation, under this translation. And that's what happened there. This point is 0, -3 in fact. Right? So we could have calculated where that point is and then still again draw the remaining points around the shape. Right? But at the end of the day, that is the result. Any questions on that?
No, sir.
All right, good. All right, I can remove these lines that I use and leave the diagram clean like that. All right, so that finishes the first part. All right, let's talk about the second part. Is there anything? No, question done. This part of the question is done. All right, let's see if there's any the second part of the paper. This is the May 2023. Let's see if there's any on question 10. Oftentimes, you can actually get 2 questions on transformation on the exam paper. All right, one of the topics where you can get 2 questions. So let's look down at question 10. If you get one of those calculation type now, the matrices. On this file, and the other file. So there's another file. This paper between 2 files. So let me go back and bring up that other file. Where is it? 2022. 2022. Where are you? Further down. On 2023. That's the second part of the paper. Where is it? So, all right. So this is the same paper, but it's split in 2 on my screen. So we're now at question 10 in this paper. All right. So that's this first part is a transformation. See, transformation. On this question 10. See, is there anything? All right. So it actually starts up here, question 10. All right. So you see, 2 questions on the same paper and transformation. So this question says, matrices A and B represents transformation given below. So they give us this one. And the good thing about this paper, and they don't do that on every paper, they are telling us what it is. Yeah? It's an anti-clockwise rotation of 90 degrees above the origin. Right? So they're helping us in this question. Remember, the anti-clockwise rotation, instead of saying anti-clockwise, they could have also said it's a rotation and give the rotation as positive 90 degrees. A positive 90 means anti-clockwise, right? Positive rotation is anti-clockwise. All right. Then now for this one, we know that the reflection in line y equals minus x. See, they tell us here represents reflection in line y equals minus x, which you should know. This question they give it to you. Oftentimes you have to know them. All right. This question for some reason they're giving it to us. It said determine the elements of the matrix C, which represents an anticlockwise rotation about the origin, followed by a reflection in line y equals x. So really, this is basically saying A followed by B. Remember, this first transformation is A. And they're saying it must be followed by the second transformation is the B transformation. So the question is really asking us for transformation A followed by B. So what they're saying is that C, transformation C, or the matrix C, is A followed by B. And how do A followed by B? A followed by B means that C is equal to B times A, because A followed by B is BA. A followed by B is BA. Let me put this right here. A followed by B is B times A. The second one multiplied by the first one. So to calculate C, we need to multiply these two in that order. All right. So let's look at it now. So we're going to multiply them. And remember, you're going to get back another reflection. But this is a reflection and this is a rotation. So the answer that they're going to get is a line. But this is a line running like this. Y equals minus x. You have a 90-degree rotation. And so the other line, you need a line that is at 45 degrees to this. So it's either going to get the y-axis line, which is minus 1, 0, 0, 1, or you're going to get the x-axis line, which is 1, 0, 0, negative 1. Your answer is going to be either this one or this one of them. Right? Because remember, 2 reflections go with 1 rotation. And the rotation angle is twice the angle between the 2 lines. So this is one of your lines. Put it in red. This is now one of your lines. You have this line already. And you have a 90-degree rotation. And it's anti-clockwise. 90-degree anti-clockwise rotation. that rotation is 90 degrees. Then your other line is either this line, the other reflection line is either that one or that one. Why is that? But the angle between this line and this line is 45 degrees. And the angle between this line that you have and this line is also 45 degrees. And that is how you can know your answer. Your answer is one of these, either the x-axis reflection or the y-axis reflection. All right, so let's work it out. We multiply b times a, we're going to get either the y-axis reflection or the x-axis reflection. All right, let's multiply them. So the b1 is 0 minus 1 minus 1, 0. And the a is 0 minus 1, 1, 0. I'm multiplying these two matrices the normal way, rows by columns, right? So we spend a lot of time doing that. That's why we had to master matrices and how to multiply matrices and so on, because you know you have to get comfortable with it. So this first value is this row times this column. So it's 0 times 0 and minus 1 times 1. That's negative 1. So already, get the negative 1 here already. I know it's a y-axis reflection matrix. And then the value over here is this row times this column, which is 0 times negative 1 is 0, negative 1 times 0 is 0. So you know this value is 0. So if I'm in the exam, I can fill it out already because I know it's one of these two. So I wouldn't bother waste time. I just write down this one because I start out with the negative 1 here. So I would know the answer already. Right? So that's why I tell you transformation is the topic that you can know the answer before you even do it. I told you that in class and you're seeing it here. This value, this row times this value, which is 0, and this value times this value, which is still 0. So this value down here is 0. And the value down here now is this row times this column, which is the negative 1 times the negative 1, give you a positive 1. And the 0 times 0 is 0. So this here is a positive 1. And that's a y-axis reflection matrix. That's the matrix for reflecting in the y-axis. So I told it would have been one of those. It happens to be this one. It would have had to be one of those two. But those are the lines that are at 45 degrees to the line y equals minus x. This line is y equals minus x. This line is y equals minus x. All right. It says describe geometrically the single transformation C. So you see, you have to know it. It's a reflection in line y equals minus x. I'm going to write it now. C is a reflection in line y equals minus x. C is a reflection in the y-axis, not y equals minus x, the y-axis, This is for reflecting in the y-axis. C is a reflection in the y-axis. Remember, the y-axis is the line x equals 0. You want to cancel line x equals 0. Line x equals 0. The y-axis is the line x equals 0. So you could have said it this way instead. But we usually just say y-axis. That's it. Any questions there? Are you okay?
No, sir.
So
Yes, sir.
Yes, sir, I'm okay.
Good. Remember, A followed by B is BA. A followed by B is B times A. All right. So, everybody okay? I heard somebody was saying something. Everybody okay?
Yes, sir.
All right. Let's see if there's anything else. All right. This is another part. It says transformation T is defined by the following 2x2 matrix. This one. So that's a transformation. Not one of our regular transformation for rotation about the origin or reflection over one of those lines, right? So it's just a transformation matrix. It says it maps this point onto this point. So this matrix maps this point onto this point. And I want us to calculate the value of T. So how it works, they're basically telling us to set up a matrices equation that we have to solve. That's what it is. So since it maps this point onto this point, right? What this really means is that the 2, 3 is mapped onto 8, 15 using the matrix T. And how it works, you multiply the matrix by the first point, and it is equal to the resulting point. That's how the transformation works. So this really means that the 1, 2, k minus 1, that's the matrix. When you apply the matrix to this point, remember, you apply it as a column vector of the for the point, 2, 3. The result is this point is 8, 15. So this is an equality of matrices equation situation now. So because the value that you want is in the second row, it makes sense to calculate this value. See what that value is equal to. That value here is actually equal to the second row here plus the 1 times the 1 column. Right? That's what it is, you know. Because if you check the 8, if you check the 8 that is here, it is 1 times 2 and 2 times 3. So the 8 right here is really 2 plus 6, which is okay. Right? But we're not trying to find 8, we're trying to find a k. So it makes sense to see what the 15 is equal to, which is this row times this column. And so we can set up the calculation and say the row times the column is basically saying that the k times the 2, which is 2k. So we can say therefore 2k and then the minus 1 times the 3 is negative 3. That is equal to the 15. And when we're solving this for the k, transpose the 53 and add it, you're going to get 2k equals 18. We take this over here and add it to the 15 with 18. And then we just have to divide by the 2. We divide by this 2 now, we get the k equals 9. That is the value of k. Easy like that. But okay with that?
Yes, sir.
Yes, sir.
All right, good. Let's see what else is there. All right, so this part is a vector. So, all right, so finish 2023 paper. You see there are 2 questions on it. That is the May 2023. All right, let's look at the January 2023. All right, we're working the more recent paper. Let's look at the January 2023 paper now. January 2023. Let's look for that paper somewhere here. January 2023. 22. All right. So January 2023. I think there's a question on number 3. Right, see there? I think this is the question I spoke to you about in class, where there was a rotation, but the center of the rotation was not the origin, and you had to construct to find the center. Remember, the center of a rotation is on 2 perpendicular bisectors, the lines joining corresponding points. Remember, I told you that. 2 perpendicular bisectors of lines joining corresponding points. That's where you find the center of a rotation. All right, I think this was that question. The persons had a problem. All right, this question said the following diagram shows 3 quadrilaterals, PQ and R on the square grid. Q and R are the images of P. So like you start out with this one. This is your object. And there's a transformation to this, and there's a transformation to that. All right. Now, the first one clearly is an enlargement. You can see it, but the thing get larger, so you don't have to guess and spell. It's clearly an enlargement, and I can know about this enlargement just by looking at it. I can know the answer before working out anything. So, for example, what can I do? I can look, for example, at this side across here, and see that it is 2 units, and the side across here now, it is now 1, 2, 3, 4, 5, 6 units. So to go from 2 to 6, you have to multiply by 3. So I already know that my scale factor is 3. I also know it's a positive 3, but the image and the object point in the same direction. So this long side down here is pointing down, or that long diagonal is pointing down, and this long diagonal is also pointing down. It is not inverted. So I know the scale factor is a positive 3. The next thing after I know that the scale factor is a positive 3, the question is how do I find the center? Remember, to find the center now, you have to join the corresponding points, right? And also remember that if the scale factor is 3, the distance from the center is also tripled. So with the view, hold on a second again, guys. Let me just get this card. Hello? I don't know. I'm waiting on Sammy to call me back. Spoke to Sammy. I'm just waiting to hear him call me back. Cool. Sorry about that, guys. I just have an urgent matter at work. to deal with, so I'll be getting a car every now and then, all right? So let's bear with me, please. All right, so another thing, so we have decided that the K is equal to 3. Remember that the scale factor affects the size of the object, but it also affects the distance from the center. Right? We're talking about this one first. We know they're going to ask us for that to describe it. We know. They're going to ask us to describe that one, and they're also going to ask us to describe how we go from this one to this one. I'm going to talk about this one and this one afterwards. Let's deal with this one first. We know they're going to ask us. All right? They're going to ask us what transformation it is and enlarge it. The scale factor we know already is 3. The next thing we want is the center. So to find the center, we join corresponding points. So for example, now these are corresponding points. And so if we join them, let me use the red ink, and extend it back. So you know the center is somewhere on this line. You need to join 2 more corresponding points. So maybe I can join this one and this one and extend it back. So if I join those 2, and go like this and extend it back, it looks as if the center of my enlargement is this point right here. So those 2 lines meet. But I can check it and make sure. Because remember, the scale factor is 3, so the distance must also be multiplied by 3. So the distance to here, for example, is 3 units. So if the scale factor as 3 is correct, and this is the center, then the distance up here must be 9 units. 3 times 3 is 9. So let's look at it. So as I said, no, this distance is 3. From here to the object is 3. The scale factor of 3 on this distance of 3, take it out to 9. I'm going to check if now this distance out to here is 9. If it is 9, then this is truly my center. So let's check it. This distance out here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. So this is the correct place for my center. This distance is 9. So the distance from the center has also been tripled. So the scale factor is 3, and I now know my center. Once I know the center and the scale factor, I can describe the enlargement. What's coordinate of this point? This point is negative 10, 9. Up here says 9, negative 10, 9. This point is negative 10, 9. This point is negative 10, 9. That's the center of my enlargement. Negative 10, 9. So let's say they ask me to describe it. I'm sure they're going to ask you to describe it. All right. It says, on the grid, they want us first to do a drawing. All right. Let's see what they want us to do first. They don't get to the thing yet. But they ask us in part B to describe it. But they ask us something first in part A. So they said, describe fully the single transformation which maps P onto Q. P onto Q. Just realize it's an enlargement of scale factor 3 about the point negative 10, 9. We can write that. We're going to come back to the first part afterwards. Let's just answer this part first. So transformation Q is an enlargement of scale factor you can write K equals 3 if you want about the point. I'm talking about the center point. Negative 10, 9. That's where the center of the enlargement is. Everybody good with that? Everybody okay with that?
Yes, sir.
All right. Now, let me just go back to this part first before we deal with the last transformation from this one to this one. Right? Let's talk about the other part A first. But they're asking us to do a translation. Right? So they're asking us to do this translation. It says, on the grid on page 9, draw the image of quadrilateral P after a translation 10, negative 4, and label P prime. Now remember, 10, negative 4 means 10 units to the right and 4 units down. So you're moving it 10 units to the right, 4 units down. All right? And to get P prime. Let's go and do it. 10 units to the right, 4 units down. All right, so I'm going to take this off. Since we already did this construction to find the center, this line and this line. Let me just take those off and get those out of the diagram. We deal with the enlargement part already. And let me just take off those lines. I'm now going to do the translation on this. 10 units to the right, 4 units down. Right? So starting with this point. I'm going to do 10 units to the right, 4 units down. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the right. Make sense? It is at -5. And if you add 10 to that, it's going to go all the way. Oh, that's a, sorry. -7. And if you add 10 to that, it's going to come over to 3. Right? Here's 3. Good. That's 10. All right. Then it's going to come -4. 4 units down, which is 1, 2, 3, 4. So let's check it that again. If it's at 7 and you go down 4, it's going to come down to 3. Good. Come down to 3. So this point up here, this point up here is coming right there. And once you know that point, you can literally draw the same shape around it. And we know the same shape we're going to get. The entire quadrilateral is going to be transformed right there. So we can just draw the same shape around it. Let me draw it in blue. So this is the point up here. I'm just going to draw the same diagonal here that this is. Same diagonal here. Same diagonal this side. Same diagonal this side. And I usually want to do this with translation, guys. I know that the shape stays the same. And then now, I'm going 2 diagonals down. If I want, I can say, okay, I have this cross piece, and then this piece now is 3 units down. I'm coming 3 units down here. Right? So this diagonal is coming here. This one is coming here. Or that slant piece is going there. That is my quadrilateral. Let me take this out there. That's it. Right? Same shape. And then some labeled P prime. So this is P prime. P prime. If you want, you could do this because you could do this 10 to the right and 4 down with all the points in number. Usually with a translation, you move 1 point and just draw by the same shape around that 1 point. All right. What else I want us to do? That was P prime. The next thing I want us to do is reflection of it. They want us to reflect in the line y equals 0. So you have to know that the line y equals 0 is actually the x-axis. You see? You have to know that the line y equals 0 is really talking about the x-axis. I hope everybody know that by now. So we tell you to reflect in the line y equals 0. Y equals 0 is the x-axis. So they're asking us to reflect in the x-axis. All right, so let's look at it. So I'm going to take this now. I'm going to reflect it in the x-axis. Reflection in the x-axis. All right, let me take off these red lines. All right, so let's do this in red now. So I'm going to highlight the x-axis in red. I want to do reflection in the x-axis. Remember, when you do the reflection, image distance equals object distance. Do it 1 point at a time. So this point here first. Let's say we're starting with that point first. It is 1, 2, 3, 4 to the mirror line. It's going to go 1, 2, 3, 4 on the other side to here. That's the first point. Then this point up here. I can say this point over here. It is 1, 2, 3, 4, 5, 6 to the mirror line. It's going to go 1, 2, 3, 4, 5, 6 on the other side. It's going to come to here. Do it 1 point at a time. Can't go wrong. And then it makes sense that this point is coming the same distance down right across from it. All right? So it's coming to here. This point is coming to here, right across from this one. All right? And then this point up the top now. It's going to go 1, 2, 3, 4, 5, 6, 7 to the mirror line. It's going to go 1, 2, 3, 4, 5, 6, 7 to the other side to here. But I figure out that point as well without counting. It's coming to here. So if I take these out now, join my points, then this is my image right here. Let's draw it in red. after I do the reflection. This now is a point, is P double prime. Are you okay with that?
Yes, sir.
Yes, sir.
Understand, sir.
All right, good. So we did the first part, right? So I've completed this part of the question and the first part of P. All right, let me leave those on it. Then now we come down to here now, which was first to draw quadrilateral, describe quadrilateral R. Describe fully transformation when it must P onto R. So we're going to look at P onto R now. All right, how do we go from P to R? Let's look at it. So we're talking about how do we go from this one to this one now. Let me take off this red line. How do we go from this one to this one? All right. So look how we can break it down now. Let's say we focus on this side, on this diagonal, from the top to the bottom. Pick a side, it's not letter then, remember the vertices are not letter. You could letter them. But let's say we take this down to here. It corresponds to this cross here. So this that was vertically down is now gone that way. So it has been rotated 90 degrees down that way. If you look at this as a tail, let's think of this as a tail. Let's look at it. You think of this point as the tail of that arrow right here. And this is the tail here now. It means that it has been rotated down 90 degrees this way, such that it is now going across that way. Right? So you can see it, the rotation of anti-clockwise 90 degrees down this way, but the tail is now down. And what was vertical before is now horizontal. What was vertical before is now horizontal. So you already know it's a clockwise 90-degree rotation. So you know the angle already because vertical has gone to horizontal. That's how you know the angle. And you know the clockwise because, as I said, I chose this point or I chose this arrow and I realized the arrow that was down has been rotated and is now pointing this way. All right? So I know it's a anti-clockwise 90-degree rotation. The question is now, where is the center? Remember, you cannot use the matrix, you know, because the matrix, the rotation matrices that we know, the anti-clockwise one, remember, is 0, 0, minus 1, 1, 0. You might be tempted to say, okay, you want to use that matrix, but no. That matrix is not related, no, because that matrix is only when the center of the rotation is the origin. Center of rotation, you know, is not the origin. You cannot assume it's the origin. It's clearly not the origin. All right. So this is the challenge that a lot of persons had with this question. Most times the questions are set up with this being the center of rotation. And if this was the center of rotation, then for example, the distance to this point up here would be the same distance to this point out here. Those are not the same distance. No, not that point, sorry. This one down here. But right? So this peak on the bottom, this one. The distance to here will be the same distance to here. So clearly this is not the center because this is longer than this. So clearly the origin is not the center of this rotation. All right? All right. So we're going to have to find the center. So remember the center is on the perpendicular bisector of lines joining corresponding points. So the first thing you want to do is choose two corresponding points that you're going to use. All right? Two corresponding points. So I know already is at 90 degrees clockwise rotation. So anti-clockwise. So let me write it like this. Already I know it's a 90 degrees anti-clockwise rotation. I just need to find the center. Because rotation has three components: angle, direction, and center. I have the angle, I have the direction, and need to find the center. To describe it fully, I have to find the center. Center is not the origin this time, so we have to construct to find it. So you need two perpendicular bisector lines joining corresponding points. So I can maybe use these 2 points. These are corresponding points. And I can do a perpendicular bisector of this one. And I need 2 more corresponding points. I can maybe use these 2. And those are corresponding points for real, for sure. So I need a perpendicular bisector of Mr. Green. I need a perpendicular bisector of this, and I need a perpendicular bisector of that. So what I need now, let me zoom it up. I need a line going like so, for this line, and a line going like so, on this line. And where they meet will be the center of the rotation, all right? But we have to construct it properly. You can't just guess it, we have to construct it properly. All right. Now, let's look at it. Let's look at it. I'm trying to go step by step so you can understand. So to do the perpendicular bisector of this line, first thing you need to find is the midpoint. You need the midpoint. All right. So you can get the midpoint quickly now. You can count from here to here. How many units down and across you go. And just go halfway of that to find the midpoint. So from here to here, we're gonna go 1, 2, 3, 4, 5 units down and 1 across. So the midpoint is 2.5 units down, half across. So it'll be 1, 2.5, half across. It means that right here is where the midpoint is, right there. So if you're in the exam, you can actually put your protractor now on this line, protractor on this line, like so. And measure off the 90 degrees over there. All right? But we can also use what we know. Right? So we want the perpendicular now from this line. We want the perpendicular now to here. It's supposed to go like that. Right? All right, let's do this other line first. I'll find the midpoint of this other line first. So this line now is 1, 2, 3, 4, 5, 6, 7, 8 down and 2 back. So the midpoint is going to be 4 down, 1 back. 4 down, 1 back. So the midpoint of this line is going to be 4 down from here. 1, 2, 3, 4 down, 1 back. So it's right here. That's where the midpoint of this one is located. So far, so good, students. So I've located 2 midpoints. So far, so good. Everybody right so far?
Yes, sir.
And then again,
Yes, sir.
for this one, what you could do, you could put your protractor on that again and measure off the 90. All right. We can also calculate the 90 by using gradient. I use gradient to know. So watch this now. What's the gradient of this line? Rise over run. Go from here to here, for example. It is rise 4, 1, 2, 3, 4, run 1. So that's 4 over 1. It's gradient of this line. You want a perpendicular gradient. Perpendicular gradient of this is minus 1 over 4. So to get the line from here that has a gradient of minus 1 over 4, we're going to rise negative 1, run 4. From here, rise negative 1, run 4. So we're going to rise negative 1, just come down 1, and run 4. 1, 2, 3, 4. So the perpendicular line of this line to that point passes through here. Remember, I said I could jump to the protractor, and I said the first line that I want, first perpendicular bisector is this line. Is this one. That one is first perpendicular bisector. That's the first one. I need a perpendicular bisector of this line now, which is the one passing through here. So we can use the same gradient again. Remember, if you have a protractor, you can do it with the protractor. Just measure the 90, right? And draw the line. But you can also use gradient. What's the gradient of this line? Go from left to right. We're going to rise 1, 2, 3, 4, 5 down, and run 1 across. All right? Or we can use from to here, it is rise 1, 2, 2.5 down, and half across. We can use the 5 and the 1. Right? 1, 2, 3, 4, 5 down, that's -5. We rub this out now. The other line gradient, that's -5/1. Right? Go from here to here, that's the gradient of that line. Rise -5, run 1. So the perpendicular gradient to that, the perpendicular to that, would be the negative reciprocal of this, which will be 5, which will be, 1/5. Flip it and change this and you get 1/5. So we need a gradient of 1/5 from this. But since we're working in half, right? We could put half over our 0.5, 0.5 over 2.5. We'll do it that way, 0.5 or 2.5. So we'll rise 0.5, run 2.5. Right? Let me show you the 0.5. Let me show you how I get the 0.5. Let's do it to the 0.5 and show you. So I'm basically saying go from this point to this point in the middle. It is rise -2.5. So it's rise -2.5 and run 0.5 across here. Run 0.5. So the perpendicular gradient to this, we have to flip it and change the sign, which will be 0.5 over 2.5. That will be the gradient of the perpendicular line. So from here, I can rise 0.5 and run 2.5. Watch it. Rise 0.5 will take me to here. And then run 2.5. So this is the 0.5 first, and I run into 1, 2. So you see, it takes me right back to that same point. That also is a point on the perpendicular bisector. So this is the point on the other line as well. Other perpendicular bisector, so we'll go like this. That's my other perpendicular bisector. And just coincidentally, I did it in a way that both of them intersect right here. That is the center of my rotation. So those are my two perpendicular bisectors. That is the center of my rotation right here. But good so far? I'm going to prove now it's the center of my rotation by checking the distances to the points. But good so far? Are they okay so far? In terms of how I got the center of the rotation?
Yes,
Perpendicular
sir.
bisectors of the lines joining corresponding points. This question gave a lot of people problems in January 2023. This is how it was supposed to be. This is how it was supposed to be done. All right. So I'm gonna take off these construction lines now to test if this is the true center. This center is really the center, right? I'm gonna take off these lines and leave the center point. All right. Now, basically, we are saying this point rotated down to this point. So basically, if I draw a line from here to here, and a line from here to here, it must be 90 degrees. It is. This is 90 degrees. You can see it. So the rotation, this point rotated down to here. And you can also see that this distance and this distance is the same. So yeah, that first point is good. That looks like my center in truth. Let's do this point up here now. Here and here correspond. I'm saying that for the straight line from here to here, and do a straight line out to here, this must look like 90, which it does. It means that this point was rotated down to here. You can see it. And you can see that this distance is the same. But that is just checking if this is my true center. And if I choose this point, this to this point, if I check it again, I rotated this point about this center down to here. See, you can see it even on this little sketch that is 90 degrees. I mean that this point was rotated as well, 90 degrees this way, onto there. And you can check the last point, which is over here to down here. And this is the center again. So I can check it. Draw a straight line onto here. So draw it down to here. I can see that is a 90-degree angle, even on this hand sketch. That means that this rotation is down here, 90 degrees. So this is truly my center of rotation right here. What point is that? That point is negative 4,2, negative 4,2, this point, negative 4,2. And so I can describe my rotation now. It's an anti-clockwise 90-degree rotation. Remember, the rotation is this way, from here down to here. It's an anti-clockwise 90-degree rotation about this point, negative 4,2. So I'm ready to describe it now. I don't know how CXC set this, but they did. A lot of persons have problems with it, but that's how it is done. So R is an anti-clockwise rotation, anti-clockwise 90-degree rotation, about the point. What is it again? Negative 4,2, negative 4,2. Okay. Negative 4, negative 4,2. I've seen plenty of people struggle with this question because they don't know about finding the center of a rotation with two perpendicular bisectors. Students in this class must know about that, not in the foolishness. You must know this method. Find the center of a rotation. Two perpendicular bisectors of the lines joining corresponding points. I want you to watch over the video, right? And try the question yourself. Find the center of this rotation yourself. Remember, the perpendicular bisector is a join the corresponding points, find the midpoint, and you can get 90 degrees off the midpoint. That's your perpendicular bisector. Because this was on graph, I could have used gradient. If I know the gradient of the line join the corresponding points, then I can use a perpendicular gradient, which is a negative reciprocal. But you could use a protractor as well. Get the perpendicular from the midpoint. Any questions on that? Any questions on that?
Yes, sir.
Somebody have a question? Everybody okay? Everybody all right?
Yes, sir.
Yes, sir.
Good. All right, so that finishes that paper. That was the January 2023. All right, we're gonna look at the 2022 papers now. 2022, so one comes up first. There's the June or the January 2022. Let's see. 2022 I'm looking for. 2022. All right, here is June 2022. All right, so June 2022 has a question number 3 and also a question number 10. All right, 2 questions again on this paper. A lot of the time they say 2 transformation questions. So one here, January 2022. So give us a number of shapes here. He said the diagram, it says the diagram below shows 4 shapes, P, Q, R, and S. P, Q, R, and S on this grid, right? So they put this one in black. So I guess maybe this one is your object. And then these are images. Right? I see this one right here, so I know this one clearly is an enlargement, right? That one clearly is an enlargement, and I know already the scale factor is 2 and it's positive. Why no? Because this side up here is 1 unit, this side up here corresponding side is 2 units. So I already know the scale factor is 2, and I know that's a positive 2 because the image and the object point in the same direction. This base down is pointing so, and this base is also pointing the same way, this way. All right, so I already know the enlargement. I just need to find the center of the enlargement. All right, so it looks like this is the object, and they do a transformation to this and a transformation to that. All right, so let's go. All right. Question says, describe fully the single transformation which maps P onto Q, see, onto R, and onto S. All right, see? They must answer that. So we're going from P to Q to R to S. Let's talk about P to Q first. P to Q, these two. This go to that. Believe it or not, this question give a lot of people problems. Believe it or not, give a lot of people problems. Now, if I look at this, I can see it's a rotation. But plenty people might think it's a reflection. Remember, reflection reverses orientation. So if I give the points, letters, right? Like for example, if I call here A, I'm talking about on the P now. I call here B, I call here C, I call here D, E, and F. I'm doing the same thing on this one now. So the point at the 90 and the 90 right here, right? Which is between this and this is the A, right? So the corresponding to that would be here. So this is my A now. That will be my A prime. If I'm working on this now, that will be my A prime. The point out here will be my B. And this will be my C, this will be my D, my E, and here will be my F. So this will be clockwise, right? Clockwise on this. But this also be clockwise. A to B to C will also be clockwise. So because the orientation is not reversed, I know it's not a reflection. I know it's not a translation now, because remember, translation, the image and the object were the same. So it's not a translation, it's not an enlargement, because an enlargement thing gets larger. I told you in class that oftentimes a reflection and a rotation can be confusing. You can have a situation where you're not sure if it's a rotation or a reflection you have. All you need to do is check the orientation of the letters on the object. If the orientation remains the same, then you know it is not a, if the orientation remains the same, then it's a rotation, not a reflection. Reflection reverses orientation. Let's say it again just to make sure. If the orientation is reversed, you know you have a reflection in a line. You have a reflection in a mirror line. So this is not a reflection because the orientation on this is this way and on this is the same way if you use corresponding points. So you know the orientation was not reversed, so it's not a reflection, it is actually a rotation. This is a rotation. This is a rotation. Remember, you cannot just say it's a rotation. You know it's a rotation, you know. It's a rotation. The first one is a rotation. But you cannot just say it's a rotation, you have to give the three components of rotation. What are the three components? You have to give the angle of rotation, angle, you have to give the direction of the rotation.
And the center.
Good. And you have to give the center of the rotation. Good. Beautiful. You have to figure out each of those. The angle, the direction, and the center. All right, let me move this a little bit out the way. I don't want to take it off the screen. And then we'll just deal with each of them. Eh? So first, the angle of rotation. All you need to do is look at what happened to one side. So for example, this base side, if you come from this corner out to this point here and put an arrow on it, and you draw it the same way on the image, which is from this corner out to the point, and put the arrow out to the point. You see the thing turn around this way completely. It has made a complete turnaround. It was first facing this way and now it's facing that way. So it's a turnaround of 180 degrees. So this to this is a complete turnaround of 180 degrees, a 180 degrees rotation. So you know already that the angle is 180 degrees. Now, because it's 180 degrees, the direction can either be clockwise or anti-clockwise. Because I could say this turnaround fully this way. same result. I could say turn around this way. When it's 180 degrees, it don't matter if it's anti-clockwise or clockwise, especially if you're just looking at it. So for the direction, you can say clockwise or anti-clockwise. It doesn't matter. Clockwise or anti-clockwise. 180 degrees, a full turn. When you turn to the right or turn to the left, all the way around 180 degrees, the result is the same. So you can say clockwise if you want, or you could say anti-clockwise. Anyone you say will be still the correct. Anti-clockwise is the direction. The question is now, how do we find the center? How do we find the center? Remember, center is on the two perpendicular bisectors of lines joining corresponding points. Remember also that the center is the only point on the rotation that does not change, it does not move. It's an invariant point. So if you can look at these two shapes, this shape and this shape, and say which point don't move. They are on each other, you know. They are connected, you know. So the center must be on them, because they are connected. Once they are connected, it means that the center of rotation is on it, because they are connected. So the center of rotation is on it. When you rotate something from a point that is not on it, they are not connected. So if I have a shape, for example, like a L, like this, and I rotated L about this point, then this point is gonna stay on it. So like I might maybe get a shape looking like so now. I'm kind of trying to draw it, right? Something like so. If I rotate this point. So once the image and the object connected, it means that the center is on it, it's on the object, right? Because if I rotated instead, if I had, for example, this shape, put a rectangle. If I had this shape and I rotated it about here, right? Then the image, for example, of this point will come up to here, so I rotate about here, so this point will come up to here, right? So we get a point here, so. And then this point now will come down to here, because this distance, you know, like you're taking this and you're rotating it over like so. So it will come over to here. Right? Something like that. So one across. All right, I'm not doing it so good. But the point is, they would not be on the same diagram. When the center is away from it, when the center is off it, you're not getting it. You're getting the image and the object are two different places. Right? They're not at the same place. Right? And they're not joined. They are two separate locations. The image and the object will be somewhere different. So I'm just trying to get it the right way. So I said that 1 point, rotate, this will come up here, so. And this point, this horizontal will come up here. And so basically, that's how it will go, you know. So it will go. Yeah, if you rotate about this point. If you rotate that, rotate this about this point here. That's where it's gonna go. Right? That's where it's gonna go. They are located in two different locations, but when they are joined like this, you know that the center is on it. The center is on this shape somewhere. So rotate about some point on it, because they are connected. So if you can figure out which point on it don't move, then you can find the center of rotation. Looking at it, the point to me that doesn't move is right here. That is the point that stays the same, because it is the center of this side and this, and the center of this side and that. It is the point that doesn't move right here. So I would say that this is the center of my rotation. So you can check it in now. So this point down here, rotate 180 degrees over to here. You can see, let's check another point. And then this point up here, so rotate 180 degrees over to here. And that's correct. And then this point out here, rotate 180 degrees over to here. So this in fact is the center of rotation. But let's say I didn't figure it out that way by looking for the invariant point on the diagram. And I said it's on the diagram itself because they are joined. Once the image and the object of a rotation are joined together, the center of rotation is on the object and also on the image because it's an invariant point once they are joined. All right? And it is the point that does not move. Well, let's say I didn't figure it out. What you need to do is join the corresponding points. Okay, try and find two perpendicular bisector lines joining the corresponding points. So I would, for example, join this point and this point. If I join them, I will get that. And I would want the perpendicular bisector. So this is the midpoint, you know, so my perpendicular bisector will be on this line, right? I'm not going to draw it. I'm marking the midpoint first. Then I will draw this one, join this point and this point. And the perpendicular bisector will be somewhere on this line. But you see, both of them, the perpendicular bisectors will meet right here anyway. So in this case, because they're joined, then when you join the corresponding points, center of rotation is the point of intersection of the corresponding points. Because the perpendicular bisector is just the point. The perpendicular bisector is just the point now, you know. There's no line on it, it's just the point. So this is a center point. If you want to look at it that way, if you join corresponding points, you see that this is a center point as well. All right, but remember, guys, when the image and the object of a rotation are joined together, the center point is on the object and on the image as well. It's an invariant point. It is a point that does not move on the rotation. So in this question, it is right here. And you have to give the coordinates. So no, the center of rotation is the point 77. See, 7 across 7. So the center point is 77. 77. But understand that? But good at that? So
Yes,
P
sir.
to Q is an 180 degrees, whether clockwise or anti-clockwise, don't matter which one you say, about the point 77. Let me write it. P to Q. P to Q. I'm just going to say clockwise. So this I'm going to use clockwise, but I use anti-clockwise just as well. I'm going to say transformation map P to Q is a clockwise 180 degrees rotation about the point 77. And when we're describing a rotation, you have to give the name, rotation, the three components: angle, direction, and the center. You cannot leave out any one of them, otherwise you're not going to get the marks. See what they give? They give 3 points for this one. But you have to state all 3 things: angle, direction, and center. All right. So let's continue. R now. How to go from Q to R? Let's look at Q to R. Sorry, P to R. P to R. Let's look at it. Going from P to R. So let me take this off. P to R. All right. So P to R now is from this one to this one. Now clearly that's a reflection, guys. Orientation has reversed. Orientation has reversed. From here to up this edge, this way. And from here to up this edge is now this way. So the orientation will reverse. So you know you have a mirror line somewhere. The mirror line is halfway between them, between the corresponding points. So between here and here, for example, you want a halfway mark, looks like here. Same thing between here and here. The halfway mark is here. So this is the mirror line. Which line is that? That line is a vertical line through 1. So it's x equals 1. This line is x equals 1. So this reflects to this in the line x equals 1. But can I say that? Reflection in the line x equals 1. So the reflection component of a reflection is just the mirror line. So let's take the equation of the mirror line. So P to R is a reflection in the line x equals 1. But I can agree to that?
Yes, sir.
All right. So we're going to write that. A reflection in the line x equals 1. Let's consider that. A reflection in the line x equals 1. Vertical line x equals 1. That's it. Just give the name. A reflection only has one component, the mirror line. Give the equation of the mirror line. That's how you describe a reflection. A reflection in the line x equals. Some people say reflection through the line, or reflection over the line. Don't matter. That's why I said to say the name reflection and the mirror line. The equation of the mirror line. Then S now. S is our enlargement, right? S. Let's erase these. S now, we're going from this to this larger one. So it's an enlargement. Enlargement has two components, a center and a scale factor. You can figure out the scale factor by looking at it. First, the scale factor is positive because the image and the object point in the same direction. See? It's pointing so, it's pointing so. So you know the scale factor is positive. And the size of the scale factor, you can outgrow by what? Multiple. So you can use this corresponding side. This is 1 unit, and it has grown to 2 units. So the scale factor is a positive 2. So we already know that the K equals positive 2. The scale factor is 2, positive 2. The next thing we need to know now is the center of the enlargement. To find the center, you join the corresponding points. So I can join this point and this point. So somewhere on this vertical line, if I draw them, see? Center is somewhere on this line. Then I can join this point and this point. Or I can join this point and this point. Those are corresponding points as well. So I can just join those two. So my center of my enlargement is here. That's the center of my enlargement. And then I can check it. But remember, the scale factor of 2 also works on the distance of the center. This center I'm getting is 711. So this center is 711. And I can check it. But the scale factor of 2 also works on the distance from the center of the enlargement. So I can check it. Look. You can check it. That center is correct. This point and this point corresponds. Was it doubled? Yes, because this is 3 and this is now 6 down to here, so it was doubled. Distance was doubled. Right? Try another point. Let's say we're trying this point and this point. Right? Was that distance doubled? Yes, because look, how much I show say double. We go from here to here. I go 1, 2, 3 across and 1, 2, 3, 4 down. But to go from here to here, I have to go another 4 across. 1, 2, 3, 4 across. So I'm going 1, 2, no, not 4, 3 across, another 3 across. I'm going 6 across. 1, 2, 3, 4, 5, 6 across, and 8 down. 1, 2, 3, 4, 5, 6, 7, 8. So you say this distance was 3 across, 4 down. It has doubled to 6 across, 8 down. So it proves to me that this is the correct center because the distance has doubled. Sometimes instead of trying to get the distance this way, you know, guys, you can just use the components, you know, how much across, how much down, you know, because they relate to this distance just the same. But then you could also just look at it and say that if I draw a straight line through here, then this length is doubled down to here. Same length, double. So the scale factor is in fact 2 because it, and this is in fact the center of the enlargement. So I can write that now. I find the scale factor and the center. So I'm good. So I can say it's an enlargement. S is an enlargement. S is an enlargement of scale factor. You can say K equals 2, you want. About, you enlarge about a point. This is how you rotate about a point, you enlarge about a point. About the point 7, 11. If you don't stay at this point, you're not going to get the full marks. 3 marks to this one again, too, you know, see? 3 marks. So you have to get it, you have to give them a right scale factor and give them the right center. So maybe you get that, maybe you're getting 2 marks for finding the center. Right? And 1 mark for the scale factor. The tail factor is pretty obvious. That is it. But good so far? But okay
Yes,
with that?
sir.
All right, next part. It says, on the grid provided and feature, draw the image of a shape P after a translation negative 2, 3. So negative 2, 3 now means you're coming 2 to the left. That's what this negative 2 means. 2 this way. And 3 up. This positive 3 means 3 up. So you're going 3 up. That's what this means. You're taking a point, 2 to the left, 3 up. You're going to move it 2 to the left, 3 up. And it's P you're moving again, right? P. Same shape, P. I just need to move 1 point. Let me take this off. I just need to move 1 point and then draw the rest of the shape around that 1 point. Because it's translation, shape remains the same. So I'm going to use here. Move that point 2 to the left, 3 up. 1, 2 to the left, 3 up. 1, 2, 3. It's coming here. So if this point is coming here, I can draw the rest of it around it. I can draw the shape around that point. So I'm putting in this like a slant piece first. I put in this piece which is 2 units long. I put in this piece which is 1 unit up. I put in this 1 unit across. And this is 2 units down. And I complete with this side. That's my shape. After my translate. What am I supposed to label it? Which I tell them must label it something. What am I supposed to label it? Label it T. Label it T. This is T. See that, guys? 2 to the left and 3 up. Let's do it with 1 point and you can draw the shape around. Because the same shape around that 1 point. But okay with that?
No, sir. Can you please that over?
Do it out. Which part of it you don't understand? Tell me which part of it you don't understand.
The rise and the run, sir. Just do back over that part.
All right. All right. So when they give you this as a translation, this first value is the horizontal movement of the points. The combination of horizontal and vertical movement of the points. And the second value is the vertical movement of the point. Now, this first value is the horizontal movement. If it is negative, you go to the left. It is negative. If it is positive, you go to the right. This is a negative 2, so I know that I'm going to move the points 2 units to the left. So if I have a point right here, I'm applying this translation, it's going to move 2 units to the left because of the negative. You understand that part first?
Yes, sir.
All right. Then this 3 now, sorry. Then this 3 now, or this second value is a vertical movement. Can be up or down. If it's positive, you go up. If it's positive, you go up. Positive, if you go up if it's positive. But if it's negative, you're gonna go down. Negative, you're gonna go down if it's negative. Right now is a positive 3. So it means that I'm moving 3 units up. So that's why I'm gonna put the 3 units up right here. So the combination of the horizontal movement and the vertical movement. So if this is a point, this negative 2 means 2 units to the left. That's why I'm gonna draw the arrow 2 units this way. And this 3 means 3 units up. So all the points on my image, on my object, are gonna move 2 units to the left and 3 units up. Understand that so far? So I know what the movement is gonna be.
Yes, sir.
All right. I just need to construct it now. So I'm gonna go on the image on the diagram. Do it over. Now technically, all these points, all of them, move 2 units to the left and 3 units up and now. But because I know that translation does not change anything on the shape, the size and the orientation, everything stays the same. I don't have to move all the points. I can just move one point and just draw about the same shape around that one point. So I decided that I'm going to use this point to start. I'm going to move it 2 to the left. I remember we do negative 2, 3 now. This negative 2 means 2 to the left. 1, 2. 2 units to the left. And then this 3 means 3 up. 1, 2, 3. Means that this point is coming right there. So I'm putting down that point first. So if this point is coming here, and the shape must be the same right there, so then I can draw all the other pieces of this shape around this point. So starting at this point, as if I'm here, and I'm here now, this piece would move to here. Agreed? Agreed?
Yes, sir. Yes, sir.
Yes, sir.
And this piece up here would move to here. Agreed?
Yes, sir.
And this vertical piece would move to here. And this piece of the top, at the top, will move to here. And this piece down here, which is 2 units, would move to here. 2 units, same here. The size is the same shape. And then now this line would complete it. Complete it. So this is my shape. And if I check any other point, this says 2 to the left and 3 up. So if I check this point is this point, you know, correspond to that point. You know. 2 to the left, see there, 1, 2 to the left, 3 up. 1, 2, 3. See that now?
Yes, sir.
All right, so the person who originally asked me to explain, they're good now?
Yes, sir. Yes, sir.
All right, beautiful. Beautiful. I think that finishes that question now. Translation, yeah, question done. All right, let's move on to another one. More maths equals better maths. I think there's a number 10 on this paper. 2022. June 2022. Yeah, there's a question 10. Transformation on question 10 on this paper. I tell you, transformation is a big topic. Okay? I can get as much as 2 questions on the paper. Right? That's why you have to master this topic, and it's very easy. This is what you call a show marks question. You know? All right, so here's another question where they're giving you the matrices. So I don't know if in recent time they have decided to start telling you what the matrices are. I don't know. But I still want my students to know. I see they change what they do so often. I still want you to know the matrices. Don't assume that they're gonna tell you. All right, don't assume that they're gonna tell you. When this question they give us a matrix A, similar to one that we did earlier, and they say is a rotation 90 degrees anti-clockwise about the origin. Remember, instead of saying anti-clockwise, they could have said positive 90-degree rotation. Because anti-clockwise rotation is positive. Remember, clockwise rotation is negative. All right? And we know that this is the matrix for that. You must know them. And then this now is the y equals minus x reflection. It's almost the same question we did earlier. No? And I said now, write the coordinates of P prime, the image of this point, 711, under the rotation of 90 degrees about the origin. So it's like we're applying this rotation matrix to this point. That's what they want us to do. All right, and you apply it by multiplying. So the answer for this one would be this. You apply the matrix 0, minus 1, 1, 0. Apply to the point P, which is 711. This is how you calculate it and you work it out. So it's a row by the 1 column. Remember, we must not do this now. So it's a 0 times 7, which is 0, and then negative 1 times 11, which is negative 11. And then becomes 1 times 7, and the 0 not going to change anything. The 0 not going to change anything. So this is just 1 times 7, which is 7. So it means that P prime is from this point. It's calculation for it, minus 11, 7. This is a column vector for this point. It's an answer for the point. You cannot leave this. Man, you're pressing the wrong thing. You cannot leave this as the answer. A point is written like that. But this is how you calculate with them. But all right with that?
Yes, sir.
All right. Next one says, T is a combined transformation, A followed by B. Remember, A followed by B is B times A. B times A. I can know the answer already. Since you did a 90-degree rotation and you did a reflection line y equals minus x, remember on the graph, because if you look at the graph, I'm telling you, we can know what the answer is supposed to be, you know. So line y equals minus x is this line, similar to the question that we did before. And you combine that with a 90-degree rotation. This is what? Anticlockwise, anticlockwise. Almost the same question. Two reflections go with one rotation. The angle between the two reflection lines is, the rotation angle is twice angle between the lines. So your other line, the other line that is going with this line, is either the y-axis reflection or the x-axis reflection. So when you work this out, it's going to be the y-axis reflection or the x-axis reflection. If it's a y-axis reflection, you're going to get minus 1, 0, 0, 1. If it's the x-axis reflection, they're going to get 1, 0, 0, negative 1. All right? So we're going to have to just calculate it, BA, and see what we get. But A followed by B is B times A. So calculating B times A, and we call that transformation T. So T then is B times A. Which one is B? B is this one, the y equals minus x reflection. 0 minus 1 minus 1, 0. Multiplying that by A, which is the rotation anticlockwise 90 degrees. 0, negative 1, 1, 0. That is equal to, multiply them in a normal way. 0 times this is 0. Negative 1 times 1 is negative 1. It's the same question, negative 1. If you complete, you're going to get a 1 down here, 0 here, and 0 here. For sure. Or I get this one, it's going to be this negative 1 times negative 1, give me that positive 1. That is it. Hold on a second, guys. Hello? I don't hear back from Summit. That's soon call. Soon call it. All right, sorry guys. All right, so that is the answer. And then I want us to describe it. That is the reflection in the y-axis. Reflection in the y-axis. So describe geometrical transformation T. T is, T represents a reflection in the y-axis. I could say is. They give it a mark same, it don't matter. T represents a reflection in the y-axis. Remember, the y-axis is also line x equals 0. That's it. Anything else on this question? No, this one is matrices, singular matrix, and so we're not doing that. We're doing transformation now. That is that. All right, but good. But okay. That's 2022. May. Let's look at January 2022 now. Doing the recent question, the recent papers. See how the questions are structured. January 2022. Another 2022. January 2022. 2022. Here. All right. So January 2022 has two questions, one in section 1, one in section 2. So this is section 1 question, part C right here. Question 3C. Okay? Question 3C. 3C is a transformation right here. So they give us that. They give us two images, a prime and a double prime. So I guess we're going to have to work with what the object is, right? So diagram below shows triangle x prime, y prime, z prime. This is this one. and x double prime, y double prime, z double prime. That's it, that one. So those two are images of another triangle. It says triangle x prime, y prime, z prime is the image of triangle xyz after an enlargement of scale factor 2 with center 5, 1. So here now, they want us to draw the object triangle. They want us to get the object. So it's almost like we're doing an inverse transformation, guys, to draw the object. This is the result of an enlargement of scale factor 2 about the point 5, 1. Remember, enlargement affects two things. It affects the size of the object and it also affects the distance from the center. Just quite simply, we're going to put on the center point 5, 1. Put on the center point 5, 1. And we need a triangle that is halfway, because remember it was double to reach to this, So to get back to what the object is about, come back halfway towards the center point. 5, 1. Where's 5, 1? 5, 1 is right here. That's where the center point of the enlargement is, 5, 1. So the image, remember, is half of this because it underwent a scale factor of 2 to get to that. So it's like you're applying and to go back to the object, you apply a scale factor of a half. So I spoke about that in class. The inverse of an enlargement of scale factor 2 is an enlargement of scale factor half about the same center. So if you want to go back to the object, you have to apply a scale factor of half. So you're going to half the distance from the center. So this is the center point. It's like you're cutting this distance in half. And you're cutting this distance in half. And you're cutting this distance in half. When you're done, this side, when you come to a 1 dimension, and this side, which is a 4, 1, 2, 3, 4, going to go to 2. So the size of your object is going to be something like that. But where is it? It is halfway. You just join these two, for example, and you're trying to find halfway. And you can join these two again, and you're trying to find halfway. We can figure out the third one. So let's find halfway. How we can find halfway? We can calculate this length by counting across and down. 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5, 6 down. So to go halfway, you're going to go 3 across and 3 down. Mathematics simply enough. To go halfway, you're going to go 3 across and 3 down. 1, 2, 3, 1, 2, 3. That's where this point was originally. So that is where y is. Y is right here. Now I can draw the shape now, because I know that from this point, this length is half what it was. So I'm going to draw, instead of 2 units, we're going to draw 1 unit. 1 unit. And this side, which was 4, is half what it is now, twice what it was. So it's now going to be 2. Object is 2 units down here. And then we complete the triangle. So this is x, and right down it says z. And if you check this is half of that. That is it. That's my triangle right there. Let's bring it halfway back in. But I agree with that. That's where the triangle is.
Yes, sir. Yes, sir.
But
Yes,
that's
sir.
the word. All right, good. So remember enlargement. So this is a question where you have to use the fact that enlargement also affects the distance from the center. Very important. A lot of people tend to focus on the length of the image and the object, and scale factor doubles, for example, the length on the side of the object, but it also doubles the distance from the center. So in this question, it is the distance from the center that we use to locate that point. Because we did the inverse enlargement to go from the image back to the object. The enlargement was 1 of scale factor 2. The inverse is 1 of scale factor half. So brought this halfway back towards the center to locate the points. That's what we did. All right. Let's continue. So we have found that one, right? 2 marks for doing that. Then it says, triangle x prime, y prime, z prime is mapped to the double prime one now. So they do a transformation from this one to this one. That looks like a reflection to me, you know. Let's check if it's a reflection or a rotation. If it's a reflection, the orientation is reversed, right? So X, Y, Z, and this is this way. So X, Y, Z, and this is this way. So the direction, the orientation is reversed. So when there's a reflection, all right? The reflection, and the mirror line is halfway between the points. So you see, we know the answer before we do it, you know. So I keep telling you about this topic, right? You say we must state the equation of the mirror line. Oh, they tell us it's a reflection. Okay, I didn't realize. They tell us it's a reflection, and must state the equation of the mirror line, and I call it the mirror line P. So the mirror line is halfway between the points. So halfway between here and here is the mirror line. The mirror line clearly going to be a vertical line, halfway. So halfway of that. 1, 2, 3, 4, 5, 6. So halfway is 3. So 1, 2, 3. So the mirror line is right here. That is x equals 2. So you pass through 2, x equals 2 to that mirror line P. The mirror line P is x equals 2. That's it. What to go to that? What okay?
Yes, sir.
Students?
Yeah. Yes, yes.
Yes, sir.
All right, let's go over to number 10 on this paper. There's another transformation at number 10. All right. Number 10. There you go. This 10 part C, just right here. What's this question? It says transformation T represented by this, and you must know that this is a reflection in line y equals x. Y equals x reflection matrix. That it maps this point under this point, and that is true because when you reflect in line y equals x, x and y values switch around. So a point xy map onto a point yx. When you reflect in line y equals x with this matrix. Right? See this point 2, 5, switch around to 5, 2. See, describe fully transformation T. Easy question. Reflection line y equals x. See, a question like this, and you want to just know the matrix. It's a reflection line y equals x matrix. The more you know, the better. So you don't need other information. People who don't know the matrix, you have to try to draw this on a graph or on a sketch and try to figure it out. No, we're not into that. They tell us know the matrix and done. Right? So T is a reflection in line y equals x. Describe fully transformation T. T is a reflection in the line y equals x. The more you know, the better. Easier questions are, the more you know. That's why you have to study those must-know sheets. All right, that's a y equals x reflection matrix. All right, that finishes that one. They realized it was so easy. All right, let's go. What time is it? All right, we have another about half an hour. We're going 1.5 hours already. About 1.5 hours, right?
Yes, sir.
1 hour 48 minutes.
All right, good. So we're going to do another question, maybe 1 or 2 more questions. And then we'll start. All right. Let's look at 2021. Let's look at 2021. Let's practicing some questions. We're going to do some more questions next week. Next week, Saturday, we're going to do some more questions. Okay? More maths equals better maths. We're going to do some more work tomorrow and Monday and Wednesday. It's class work Wednesday and Thursday. And then now, we're going to just practice some more. Just cement the topic next week. All right, so we're looking about 2021. All right, here's a question, 2021. 2021. All right, there you go. This is a question 3. This is a diagram of the question 3. So you realize now that the question 3, the diagram 1, we have to construct and draw and so on. The question 10 and the matrices 1. We have to calculate, right? This one says, The diagram below shows three triangles X, Y, and Z on a square grid. So X, Y, and Z. All right, X, Y, and Z. So this one is the X1, this is Y, this is Z. Looking at it from this to this looks like a reflection already. Right away, like a reflection in the x-axis. This distance is the same, right? Reflection in that line. And this one, so I go from this one to this one, a rotation. Rotation about here. At this point, rotate down to here. And so on, right? And that's at 90 degrees. But this side was horizontally this way, more vertical up this way. Alright, so like a anti-clockwise 90-degree rotation. Let's see, assuming we'll start from here. Let's see what it says. Because in alphabetical order X, Y, Z. It says triangle X is mapped onto triangle Y by a reflection. See, they tell us a reflection. We know what a reflection. We could see it. We could see it's a reflection. Why am I getting this thing? State the equation of the mirror line. They want the equation of the mirror line. So we say the mirror line is the x-axis, you know. So from this to this, it is the x-axis. Clearly, because this point reflects to this point. This point reflects to this point. And this point up here reflects to this point down here. So the mirror line is the x-axis, but they don't want it to say it's the x-axis. They want the equation. So you have to know that the equation of the x-axis is y equals 0. That's the equation of the x-axis. So the mirror line is the x-axis. Take the equation of the mirror line. So the mirror line is the x-axis. Is the x-axis. The question is asking for the equation. So you can't give this as the answer, you know. This is the answer. Y equals 0. This is your answer. This is just to identify what it is. The question asks for the equation of the mirror line. You have to put this. Y equals 0. That is the equation of the mirror line. But understand that? That's the equation of the x-axis. Next one says, describe fully the transformation which maps X onto Z. X to Z. The rotation. This one to this one. It's a 90-degree rotation. As I said, what you can do is just choose one side first to get the direction or the angle. So this side, let's say point this way. Corresponding arrow on the image will be this way. It's like the arrowhead. You can see that the arrowhead was rotated up this way. What was horizontal is now vertical. So it turned 90 degrees upwards. So the anti-clockwise 90-degree rotation. All right. So where's the center? So most times the center is the origin, and it is the origin this time because all you need to do is, all right, this point, for example, rotate to here. Let me show you can get the rotation for this point now. So what you do, you create like a what we call a L. So you go, you draw the coordinates. So the coordinates also rotating up from the origin. So the coordinates of this point are represented by this line across and this line up. So you act as if you're rotating this shape, this L shape. You're rotating it upward like this. If you rotate it upward and at that point, then yes, this is the center of the rotation. You're rotating this L about this point. So if I rotate this horizontal piece first up here, it's going to give me this vertical piece, same length. And then on the head of it is this piece. This piece is going to now go on top here. So it means that if I rotate this L 90 degrees anti-clockwise, I'm going to get that. So that is consistent, that is true. All right, I can choose another point. Let's say I choose this point. That is the L. 4 across, 4 up. If I rotate 4 across, 4 up, this 4 across is now going to go 4 up. And this 4 up here is going to come on top. And give back this point. So this point rotate to that point. I can see it. So it is true. This is the center of rotation, right here. So it's an anti-clockwise 90-degree rotation about the origin. That's what it is. Anti-clockwise 90-degree rotation about the origin. And anti-clockwise 90-degree rotation about the origin. That's it. Next part. Next part says on page 10, we have to do a translation, translate triangle Y. Show this triangle Y again. We're doing a translation on this one now, Y, for instruction. We have translation on triangle Y. What is the translation on triangle Y? Negative 7, 1. So negative 7, 1 means that if our point out here, you're gonna come 7 to the left. That's what negative 7 means. This one means that they're gonna go 1 up. That's that translation. Negative 7, 1. Negative 7, 7 to the left, 1 up. We're doing it on the triangle Y. And again, we can just do 1 point and draw the shape around that 1 point. So let's say we're doing this point. 7 to the left, 1 up. So if you're at 0, I go 7 to the left, we're going to come all the way over to negative 7 here. And then you're going 1 up to here. 7 to the left and 1 up. So this point is coming right here. Then you're going to draw the rest of the shape around this point. Use the blue. So this point was this point. So this side was how many units long? 6 units long. 6 units long. This piece, 6 units long. I'm going to draw back a line, 6 units. 1, 2, 3, 4, 5, 6. Right here. Then to go from here to here, or we can also say 2 from here is 2 down. So it's basically getting about the same shape. 2 from there, 2 down. 2 this way, 2 down to this point. That's where that point is located. Let's draw the triangle. If you want, you could do the translation on each point. With that translation, I usually just draw one point, and then draw the shape around that 1 point. That's not complicated. What I want us to label this one, I always want us to label it something. Label it what? Label it W. No, the translation was V. 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 Translation is V. Image of a translation is V. Then they want us to do another transformation, looks like an enlargement. No? Yes, an enlargement. See here? We must enlarge triangle, enlarge an enlargement, triangle X. And I want the center to be the origin. Easy. When the center is the origin, it becomes easy. But when the center is the origin, it means that you can use the matrix K0, 0K, and it maps a point XY onto KX, KY. So if you're applying a scale factor of a half, it means that your point XY is going to go to half X, half Y. So essentially, you're taking half of your coordinates. You're taking half of the coordinates on the shape. So you're half in the coordinates. And scale factor is a half. The image is going to come halfway. It's going to come half the distance closer to the origin. 0, 0 is the origin. All right, that's why we are able to use this matrix. When the center of rotation is the origin, we're able to use this matrix. 0, 0 is the origin. All right, so we're taking half the coordinates on triangle X. The triangle is half the size and half the distance from the origin. So this is it. All right, let's do it in red. So this point, the half in this is at 2, 0, that 0, 2 is going to go to 0, 1. So this point is coming right here. It's coming right here. And this point out here is at 6, 2, it's gonna go to 3, 1. 3, 1. It's coming right here. And this point up here, which is at 4, 4, you're gonna half it. It's gonna go to 2, 2 right here. 2, 2. So the image triangle of that enlargement is this. Small because the scale factors are half. It's half the size. If I draw the construction lines, you see that they meet at the center. If I join these lines, come to the center, join these, meet at the center, join these, they also meet at the center. But the center of the rotation this time is the origin. You can see that. But I don't need to draw those lines. I'm just doing it to show you that it is correct. That is it. Mr. must label that one W, last one. Label it W. W. But go to that.
Yes, sir.
All right. What time is it now? This question.
1 o'clock.
It's now 1 o'clock. We started a little after 11. So let's just do one more and call it a day. All right. Let's do one more and we'll call it a day. Let's do the 2021 January. I'll call it a day. January 2021. The next week we're gonna start back at 2020. Work our way down. More maths equals better maths every time. More maths equals better maths. All these questions that I did today, guys, I want you to redo them. Watch over the video and redo them. All right? Have to redo the questions. All right, let's finish this one and call it a day. So this is a number 3, 3C on this paper. January 2021. Right here. So we're going to be doing a transformation on this letter A. This A letter right here. This letter E. All right, let's see what they've said. Looks like an enlargement we're going to do. If I see this point up here, it looks like an enlargement. You have to go about this point. It says the letter A and the point C66 are shown. So this is point 66 and it's the letter E. All right, got it? What I want us to do. It says on the diagram, draw accurately each of the following transformation. First one, an enlargement of letter A, yes. Scale factor is 2, so we're going to be twice the distance away and twice the size about the center point 66. So that's another case now where it's better. You can't just randomly draw the triangle. You draw the triangle so that the points are twice the distance from that point. And not triangle, the A. Right? We're going to apply a scale factor of 2. So the points are going to be twice the distance from here. All right? That's key. Let's do it. So I'm transforming these points, these main points. And I can work out this one in the middle. Remember, because the scale factor is 2, you're going to get an A that is twice as large. But they have to be positioned in the right place, but the question says accurately. So this distance is going to be doubled. So you see it's on 2 diagonals. So automatically you know it's going to go on another 2 diagonals. So it's coming to here. So this point is coming to here. Distance is doubled. At this point it's coming to here. Distance is doubled to here. So from the distance from this center was this, it is now doubled to here. All right, now doubled. So this becomes the apex of that A. Then also this distance is doubled. All right, so I'm just do it one at a time. So we have that distance goes there, that point goes there. Now, if I want to know, since I know that the triangle is gonna be, the A is gonna be twice as large, you know, I can work now from this point, you know. Sorry, the pen is not picking up certain things. I can work from this point, you know, and draw A that is twice as large from this point, you know, as this, you know. Can do that. Because for example, this piece right here was just one diagonal, we call it 1 across 2 down. It's now gonna go 2 across 4 down, and so this leg this leg, which was 1 across, 2 down, it's gonna double and go to 2 across, 4 down. So I can go 2 across, 4 down. 1, 2, 3, 4. So this point is coming to here now. If I draw the construction lines from the center, you'll see it. I draw the line right through here from the center and I double it. Come down to there, you can see it. I'm doing the same thing on the other side. The other leg of the A. This leg of the A, 1 to the left, 2 down. That's gonna double. 2 to the left, 4 down to here. So this point is coming down to here. But again, if you want it, you could do it from the center point. If you draw right through, I'm doing this point. Double this distance. Right? Whichever way you want to approach it, this becomes your image A. At least those 2 legs. Let's get this cross piece now. So look at it. So this cross piece is basically it's like 1 down from the vertex right here. So it's basically gonna go 2 down from it. If you notice, there's like a space between this line and here. That also is gonna be doubled. So like it's gonna go halfway. So it's gonna come down to this line, quite 2 down, but don't quite reach. So it's gonna be like around here. But this little gap must be doubled as well. And scale factor is 2. So if you draw this on an exam paper, you get. It's not exactly in between these 2 lines, like halfway inside here. It's a little bit below, right? So it's not going to quite reach that line. But that is it. That's a good enough drawing. But okay with that? That's my enlargement. Scale factor 2.
Yes.
All right? That's my enlargement of scale factor 2. Next question says, I'll do a translation on the A. A translation on the A, -3, 2. So the -3, 2 now means they're going to go 3 to the left. That's what -3 here means. 3 to the left. Starting a point, they're going to go 3 to the left. And this 2 means 2 up. So the points are going to move like that. 3 to the left, 2 up. So you just need to move 1 point again. We're transforming this now. 3 to the left, 2 up, and then draw the shape around it. So I'm going to use this point to start. This is a different color. Let's use the blue. So 3 to the left, 2 up, right? Yes, 3 to the left, 2 up. So starting with this point, I'm going 3 to the left. 1, 2, 3 to the left, 2 up, 1, 2. This point is coming here. And then once I have that point, I can just draw about the same shape around that point. So this leg is on that diagonal. Let's draw it back like this. And this leg is on this diagonal in this rectangle. So let's draw it back like this. And then now I have to draw this piece across here. Let's put it back right here. A little bit above that line. And that's my A, my image A of the translation. But all right. One
Yes,
other
sir.
point and draw about the same shape around that point. All right, so that finishes that. Oh, that finishes that question. That's all you have to do. Good. All right, let's go over to the number 10 now. I'm going to finish after that. Number 10. Remember, guys, I wanted to redo all these questions. Redo all the questions. Watch over the video and do over the questions. Redo the questions. I've sent these questions. I sent these papers to the group. Are you ready? I think I'll send them again. They're already in the group, these papers. I'll send them again. So you can work the questions from them. Very important. Let me see. For just 10 part C. A simple little thing, 10 part C, this one. It says 10 part B. So 10B. Right. It says triangle, the right angle triangle M has these vertices, and M is transformed. So the triangle is M, right? I don't know what about call it M. So this triangle M, and it is transformed using this matrix. That's a y equals x reflection again, guys. Y equals x reflection matrix. An easy question. More things. Y equals x reflection. Switch around the points. Switch around the coordinates. More things you know, the better. Oh no, so switch out. Oh, I know it's switch around the coordinates. Because I can relate it back to function. When you're reflecting line y equals x, you get the inverse. And the inverse is obtained by flipping around the coordinates. Or I can work it out. The 1 point, or a general point. The general point is xy. So if I carry out this multiplication, 0 times x is 0, 1 times y is y. And then 1 times x is x, and 0 times y is 0. So you see that at point xy, you switch around to yx. So based on that, I know all the answers that I have to calculate nothing. It's to find the vertices of M prime. I will leave this on my exam paper. See this thing that I wrote on the screen right here, so I will leave it on the exam paper as my reasoning, especially this. And so I'm just switching around these coordinates for my answer. So I would say x prime. Well, 1 switch around is 1 1. It's an invariant point. When you're reflecting the line y equals x, because it is on the line y equals x. It's shown this one, y prime, gonna become 1 3. This point, which is 3 1, it's gonna become 1 3. And this point, which is 3 4 for the z prime, this 3 4 gonna become 4 3. And that's my answers. Do it the easy way, guys. You don't have to work it out when you know it. This is a very easy topic, but you have to study those must-know items for it to be that easy. All right? That is it for today. Are they okay?
Yes.
All right. I'm going to send the questions to the group. I'm going to send all these papers to the group, and they work the questions for me over again. 2023, 2022, 2021. The June and the January papers. I think you have them already in the group, but I'll just send them again just to make sure. I want to work these questions over again. All right, and watch the video. Use the video to help you work them over again. You have to master this topic. We see that we're getting 2 of them on the exam paper. 2 of them are getting on the exam paper. So it makes sense to know this topic. You can avoid it. All right, and it's an easy topic, especially if you know the must-know items. So study those must-know items, and the topic will become super easy, and you will know the answer for questions before you even do it. That's a level we want to get to, where you know the answers without even doing the work as yet. Because once you know those things, those main things, those must-know items, then you'll be able to know the answers to questions. All right, and sometimes you even know what they're gonna ask you. All right. That is it, guys. See you all Sunday and Monday. All right? I'm going to continue. Sunday is going to be a class activity, Monday as well. Class activity for us to understand this topic even better. All right. Bye-bye, everybody. See you Monday, Sunday and Monday. Bye.
Nice.
Okay.